So, next speaker, Marcus Denker, talking about Pharo3.
Yes, exactly. Yeah, Pharo3, which is the next release of Pharo. And before I show you what actually Pharo3, what we did and what it will be, a bit in general about it. So you have already seen Pharo already in the first talk, which was already Pharo3, because the release is very soon, and so people are starting to use the latest now. So what is Pharo? Pharo is a language and an environment where the environment means a full programming language, programming environment with code editor, debugger, and everything. It's a simple language, Smalltalk, right now very much compatible to the original Smalltalk. And it's object-oriented, it's dynamic, and especially it's extremely reflective. So that means it's implemented in itself, and you can change and inspect everything of the language directly. So the idea actually is that we want to build the ultimate programming environment. It's of course a lofty goal, and we will see how it turns out, but that's the end goal. So Pharo is MIT licensed. Our main platforms are Mac, Linux, and Windows. There are some people looking at mobile space, but that's a bit difficult because they don't allow JIT compilation to be done, and so that means it's a bit slow. We have a growing and really nice community. Very important, Pharo is improving steadily, so actually there is almost no day where there is not something being improved. Often it's of course very simple, but sometimes it's big. And we have a lot of libraries and external projects that use Pharo, like we saw in the first talk, for example, this baby mock project. So Pharo was started in 2008, but we had our first release only relatively late in 2009 in October. And since then we had all in all 5 releases, which 2.0 is the stable, which was released last March. So last year's talk here at FOSDEM was actually about what we had done for Pharo 2, and that we would release it soon. And the interesting thing is that we managed to do almost everything, or most of the things that we were actually planning for Pharo 3. The idea is that we want to do 1 release per year for the next 20 years or something like that. So that means that I will later with Pharo, in the Pharo 4 talk, I will discuss a bit what that means from a time schedule. So we started in March 2013. If you look at the bug tracker and you filter for all issue tracker entries tagged Pharo 3, then you see that it's 2021 that were closed since March. This is quite a lot. So that means this is not even 300 days, and that means these are really multiple things happening every day. So when people submit an issue tracker fix, then this fix is automatically verified by running all tests, and then we combine 3-4 of those into a so-called update, of which we have around 1 to 3 per day. And we made, since March 18th last year, we had 733 updates for Pharo 3. So that means a lot of things happened, and we still have a bit to do. So we have 40 issues tagged that we need to fix until we can release, but we hope that we will do that until March. Lots of activity means, so this graph I made in December, so it's already a bit outdated. This is the release date of Pharo 2, and this is shortly before Christmas. And you can see that the open issues stay more or less constant. So we have always a constant open issue of around 500, between 450 and 550 issues. And it's really difficult to get that down. So I always try, and we always have sprints where we try to get this down, but it's very difficult. But the interesting thing is it stays constant. So even so people open a lot of issue tracker entries, they get close too. So we managed to close 2,000 issue tracker entries within the development of Pharo 3. And one of the reasons why we were able to move so much faster than in the past is that we now have a working continuous integration infrastructure. So this is actually provided by INRIA, which is a French government research lab for computer science. And they have a central continuous integration infrastructure built on Jenkins, and we can use that to build up our infrastructure, and we use that extremely a lot. So that means every fix that someone submits is validated automatically for the latest version of Pharo, latest development version, which means it runs, in this case only on Linux, all 16,000 tests. And only if these tests are green, this issue will get tagged to be worth of human review. And we run even kind of lint-style checks to see. So for example, if someone forgets to put a comment in a class, so if there are certain small errors, they are checked automatically too. So that we do for every fix. And then when an update happens of Pharo itself, this update is validated on all 3 architectures automatically, so that it runs all those 16,000 tests 3 times. And of course, after that, there is a new version of Pharo, and that means that all issues that have been already tagged to be reviewed, they will be retested. So that means we have a lot of activity going on this integration infrastructure. One update push of Pharo triggers a lot of jobs. Once to rerun all the tests on the proposed fixes, and the other thing is we have now in the Pharo contribution CI server over 80 external projects that are validated, often on both Pharo the stable version and the unstable version. So that means that one push of an update triggers directly 80 builds on the contribution server. And the contribution server looks like this. So it's a normal Jenkins installation, but with 80 projects. Besides the continuous integration, we built a lot of other infrastructure over the years. Most of it really got stable last year, which is very interesting, so that everything comes together and pushes you forward. So we now have a file server, files.pharo.org, where you have every Pharo image that ever was, so the Pharo release of every intermediate update is available there. So if you want to check if from the version that you used 2 weeks ago, if this bug really happened there and not now, and you don't have this release anymore, you can go back. There is the whole history available there. We have get.pharo.org, which is an easy way of installing Pharo, especially in a server context. So it's a website with a description where you use wget to directly install a complete Pharo system. So if you go there with your browser, you can see how this looks like. Another one is Smalltalk Hub, which is a special kind of GitHub-like system for Smalltalk, which instead of using Git, uses Monticello, which is the traditional revision control system that was invented for Squeak a long time ago. And this one starts to get quite used a lot. So we have over 1,000 users, and due to our wonderful build infrastructure, we get around 15 million downloads of versions every day. So what did we do with all these 2,000 update issues and lots of updates? So we had a lot of small cleanups, of course. So when the philosophy in Pharo is that nothing is too trivial to be done. So if someone, while reading code, finds a typo, of course that is not really relevant for anyone. I mean, a typo, missing I in a comment, who cares? But people actually, when they read that, they actually stumble and say, someone should fix that. And if they then do the work to fix it, we will integrate it. So there is no, but this is trivial, we will ignore it. There are lots of course, code-based tunings, like performance improvements, memory consumption improvements, especially because we managed to get a couple of memory leaks in some things. There were a lot of improvements in Pharo3. And overall, lots of small improvements on the code base. So we have now a lint-style checker in the system that provides a couple of, I guess, around 80 or so checks of things that should never be wrong. So for example, if there is an instance variable that nobody uses, why is it there? It just makes people think of, why do you need this kind of state in this class? And then people do not understand anymore, and then they search around and they find, it's not used, and they lost 10 minutes of their life. So we are trying to improve all these small things. So lots of things were done there. But of course, there were a lot of larger improvements too. And not a lot of them I can go into detail. So these are actually the ones I will not talk about. So for example, we added the closure class of that used to be in Seaside. we added that into the system, so now you have a closure implementation that you can use directly without loading C-side. We have now real terminal output for standard error for Unix, very nice. We cleaned up a lot of code related to source files. We have an AST interpreter now in the system that allows you to very nicely experiment with Smalltalk-like systems by changing it. It's a visitor over the abstract syntax tree, very simple but complete, so it can actually run the whole tests successfully. We added lots of AST-related things. So, for example, there's AST-based navigation in the browser, so that you don't, in the code browsers or in the editor, so you don't need to go character by character, but you can say, okay, go to the next AST abstraction, go to the next statement. We added a nice commit tool, lots of small speed-ups and things like that. Yes?
Continuation of code, right?
Huh?
You make a continuation of code, right?
Which one?
The first bullet.
What?
No, to the left.
On the left.
Closure.
Yeah.
Continuation of code.
Continuation. Yeah, you're right. Continuation class. Blocks are closures, but if you want to program with continuations, you always needed to do it yourself, and this simplifies. So one of the bigger improvements that are actually visible to the user, so if you download Pharo, is the new inspector. And I actually want to show you that quickly if I have the time. So what does the clock say? I guess.
You are 30 minutes.
Okay, so let's quickly take the latest Pharo and start it up. Done. So if you're in Pharo, there is in Morphic in general, not only in Pharo, you have the whole, what models the screen is actually an object that is bound to a global variable called world, and you can of course inspect that variable. And so you get an inspector, and you see that this inspector looks a little bit different than or if you know older Smalltalks, you see that it's a little bit different because it has a selector at the top, which allows you to switch which kind of inspector you want to use. So Smalltalk already since, I think Smalltalk 80, since the original release, had the concept of multiple kind of inspectors, but it was always a bit hidden. So normal end-user programmers even didn't understand that when they looked at the dictionary that this was a special inspector that was not showing the real world, but how it would look like that it looks dictionary-like. And we made this now available so that you see that there are multiple kinds of inspectors for certain objects. And for these morph objects, we now have always 4 different inspectors available. One that is the standard inspector. One is a tree inspector, which is what used to be the explorer, which shows you all the state of this object nicely in a tree. Then we have a hierarchy explorer, which only shows you the morph objects and the hierarchy that the graphical things have on screen. So you can see, okay, this is a spec window, and it has a grep morph and all these things. And then we have, just as a demo, something really fun, which just shows this graphical morph and renders it inside the browser. And as this, of course, renders what you see on screen, you get a really nice effect of an endless inspector of the main screen. And if you open now here a menu, then this will immediately be copied step by step into this. So it's kind of fun.
Will this run out of memory?
No, because it just renders I think it stops at some point or something like that. I think it has a maximum depth. So kind of nice.
Yeah.
And this new inspector actually has already been proven to be very interesting. So it is used a lot in our virtual machine experiments to give us special inspectors for pass trees, intermediate representations, and showing. So there is work going on adaptive optimization, which will be very interesting, and we hope that we will see something around end of the year working, which the benchmarks you saw that Stefan showed, which will hopefully be improved a little bit for COC together with this optimizer. And there it's very useful to have this inspector because you can inspect all these things, these SSA graphs that get optimized. You can introspect very nicely. So that's very nice. Another thing that we are working on, but which is a big project, is a vector graphics backend that should replace the 70 style bitmap graphics that drives the system right now. So it's a new API for vector graphics, modern API with independent backends. For now we use Pharo. There is a Balloon 3D backend for debugging, but it's because Balloon 3D is not complete in the sense of a complete vector framework. It's not really useful. Cannot do some certain things. And in the future, we would like to directly go to OpenGL and use hardware rendering. But for now, it's Pharo. And we actually have this working in the current 3.0. There's a preview. It's not yet used to render the desktop, because that is a lot of more work to be done. But it works already like this, kind of nice. So how is this called? vTiger demo run demo, I guess. Yes. So you can see here, this is lots of shapes for the vector data, and this is rendered to make this relatively smooth animation all the time completely, while being copied around as a bitmap quite a lot. So to get this into the Morphic screen, it gets copied again, and there's a lot of copying going on, and that's why it's not really that fast, but it works. And people are starting to use that as a specialized canvas inside Pharo3. But the future will be to actually replace the canvas that renders the whole desktop with this graphics framework, and then we would have a vector-based system completely, where we could easily implement zoom of this, so that when you have higher resolution, that the graphics do not get smaller and all these things. And of course, it should speed up the whole system quite a lot if we do that. So that's quite nice. So in Pharo3 we have a canvas for that you can use in your programs, but the system itself does not yet use the canvas to do the rendering of the desktop. So then we actually did a lot of big changes in Pharo3 that are completely invisible. So one is that we replaced the Smalltalk compiler, so the compiler that takes text and makes bytecode. That was completely replaced by a re-implementation which uses the abstract syntax tree from our tools, which is very high level, so it has lots of things for, so it was actually implemented for a refactoring tool, and now we use it in the compiler, which is quite kind of interesting, gives you a lot of flexibility. And then it uses the backend, which is kind of like a high level assembly for bytecode, which is very nicely usable standalone if you want to do experiments. And you can actually decompile the whole system into this intermediate representation, manipulate it, and then re-emit bytecode, and that's extremely fast. So decompiling the whole system takes less than a second using the IR representation. But that's very nice if you want to do bytecode manipulation. All in all, the compiler is much easier to change because it's built on visitors, one after the other. And it really used the basis for a lot of really nice things that we will see in Pharo4, which we will see later. A bit on the same level is that we replaced the class builder. The class builder is a system that is there when you want to make a class, because making a class is not that simple. Because if there are already instances, you need to migrate the instances. There are different kinds of classes, so it's quite a lot of work to be done. And the class builder was really complicated. So actually, I don't think that anyone understood it. And now we replaced it with a class builder that is much easier to understand and much more flexible, because it makes a lot of things into objects that weren't objects before. And one of them is so-called slots. So now we have, for every instance variable in the system, we have an object that describes that instance variable. Right now it's purely for the same that it is in Smalltalk, so it's an instance variable, but you have an object for it. But it's kind of nice. So if you look, for example, in the current Pharo3 and you say slot all instances size, then you see that we have right now in the system 7,272 different instance variables. So for every instance variable, we have now an object. And in a second step, this will allow us to do a lot of really crazy stuff, which we will see a little bit in the Pharo4 presentation. On the same level, we have a complete new implementation of the debugger, which now separates the view from the model, and we have even two views implemented, so we can prove that it's independent. The model is scriptable, so you can actually script it using Smalltalk. It's understandable, so you can actually hack it. And there's a lot of nice research going on in Switzerland, in Bern, on this, and they have really fancy debuggers. So the idea is that they want to provide you a toolkit so that you can provide your own debugger for your own complicated system. So kind of programmer implements their own debugger to debug easier. Very nice. Another thing that we did is command line interface. So because of the build server and because people are starting to use Pharo a lot in kind of real world settings, it needs to talk better with the outside world. And one of the things that is really nice to have is a command line interface. That makes sense. Okay. So if you make a subclass of command line handler, then you can implement, just look at it, it takes 2 minutes to do, then you can implement your own command line handler. So I did one last week, which is called clean, which runs image cleaner. And it's really nice because this one now can be used in the build server quite nicely. So you can just say Pharo update, and then it loads the code update. You can print version and prints out the version, and then Jenkins can use that. Or, if, for example, we can run the tests from the command line, which is used in the build server, of course. You can do image cleanup, or you can just evaluate Smalltalk expression. Very nice. So that was already about the Smalltalk system itself, and a bit on the infrastructure level, but not technical infrastructure, but more human infrastructure. We are starting to do a lot of things too. So one idea that we made real last year too, so it's part of Pharo3, is the Pharo consortium. And there the idea is that there are companies using Pharo for their work, and there should be an infrastructure set up so that they can actually invest into their own future. Because if they use Pharo for their day-to-day work, then there should be interest that bugs get fixed, that things get improved, and that we move forward in general. And if you are a company, then you always need to do the things that you need to do to get your customers happy, so you don't have the time to do that at all. Sometimes you have, but often not. And so the idea here is that the companies can actually give money to one organization, and that organization should be able at some point to hire someone full-time to fix bugs in Pharo, so that they don't have to do that themselves. Right now we have 13 members that are real companies. We have 6 academic partners and 3 sponsors. So sponsorship is the kind of, you're not a member, but you're contributing. And it's not yet enough to pay someone full-time, but it's already quite on a good direction. So we will hope that this will continue in 2014. And here are the companies that are right now a member. Sadly, our sponsors are cut off a little bit, so have a look on the website to see them. Yeah, very nice. And this is really going in a good direction. So originally we wanted to have both companies and individuals being part of the consortium, but the problem is that the consortium is managed by INRIA, and INRIA as a government entity was not able to handle individual contributions. And so we decided for now to split these two things. So we have a consortium for companies and institutions, and we have an association for individuals, which has now around 60 members. And the idea is that at some point the consortium and association will be merged into one entity. We will see in a couple of years. Another thing that we did is we released a second book, which has more, so we have already the Pharo example book, which needs to be updated because it uses Pharo 1.1, I think, as an example. And we now have more advanced topics in the second book. So it's not really for introductory things, but it's more things on top of Pharo, like external libraries that are described, like Orasa, the visualization engine, things like that, or really deep topics, like I think there was something about exceptions and things like that. How they're implemented, how they work. Yeah, and there is a third book in preparation. If someone is interested to write something, that's always interesting. And the third book will be about Pharo in the enterprise. So more like what do you need to know if you want to deploy Pharo professionally, for example, or what kind of libraries do you have that you need in this world. Before I stop, one interesting thing we are trying to do is to have sprints regularly. And sprints are that we meet with 10 to 20 people with the goal to fix boring bugs. So to really look at the bug tracker and fix all the things that nobody ever wanted to do because it just sounded boring or complicated and not that important and things like that. And this is starting to get really efficient. So the last sprint, we managed to fix 30 bugs before Christmas. So that starts to get really nice. And we do try to do it in many places. So if you want to organize one, you're welcome. Of course, in Lille, we try to do one every month. Not all of them are really publicly announced, but around every 2-3 months we want to make a really big one with external participation. And if there are, for example, conferences, then we try to set something up. But everyone can do that if you're interested. So that's my presentation for Pharo3. And if you're interested, help is always welcome. I will present what we will do after Pharo3 until next FOSDEM, then after the break. Any questions?
Yes, maybe that's what is already done for Pharo2. I have to admit I haven't the time to look at Pharo3 now, but as I remember, the packaging about this in the system was very connected, every package to each other. Has this been resolved like with Pharo2 or Pharo3?
Yeah, so we started to work on that. Okay. And so there was a very interesting two projects. One is about bootstrapping Pharo from source code, which I will talk a little bit in Pharo4. And the other one is about shrinking Pharo down. And those projects, as people were working on that, they submitted improvements. So I think we improved a little bit the situation, but the problem is we have not yet infrastructure in place to make sure that it does not degenerate anymore. Okay. And so when we then said, okay, now Pharo3 is nearly finished, some people were actually looking at these things and then said, hey, but this is getting not better, but even worse than it used to be. So in Pharo4 we need to really build infrastructure. We need to test that there are no, because it's so easy. You fix something and 2 weeks later someone else tells you, yeah, but you are using now in the kernel this package and this is a problem. And then you think, yeah, but I didn't know.
Yeah.
So it's really a problem.
Ongoing work then.
Ongoing work, but there will be, I think, a lot of progress in Pharo4 because now multiple people actually said, oh, we need to do something.
And that's all should be based on the packaging system that was already there from the beginning, maybe, or are there ideas to use something else?
So for the real, we need at some point a real package system with imports and all these things, but this is a bit difficult to get it right. So it's very easy to get it wrong. And that is always the danger, so that we are a bit reluctant of saying, okay, this is the solution, and then it's wrong. But we will see. So at some point this will come, and we need to do experiments. The first thing I think we will do is to put rules into place that check these things, so that we define this is the kernel, and if the kernel uses something that's not the kernel, then the test is right. So that we need to add, and I think we will do that in Pharo4.
Thanks.
No. Any other question?
Thank you very much. We now have half an hour.